As we go on to topic 4 of chapter 5, multiplying two polynomials is our first objective, and we'll be doing all of these. And this is pretty straightforward. We're going to take the number, the coefficient, and multiply it by the coefficient. 2 times 5 is 10. Then we add our exponents on the variables, x to the 9th. Now in letter B, again the coefficient here is a 1, negative 1. So negative 1 times 7 will be a negative 7. Y, add your exponents to the 15th. Z to the 9th. Again, pretty straightforward, multiplying a monomial by a monomial. In example 2, we're using something we had way back in chapter 1, the distributive property, where we took a term and then multiplied it by each of the terms in the parenthesis. So what we see here, we're multiplying a monomial by a binomial, and we're just going to distribute. So 2x times 5x is 10x squared. 2x times a negative 4 is a negative 8x. Now, one of the things we're going to be doing later in this chapter is seeing something like this, where we want to factor out the greatest common factor. And notice you could take a 2x out of each of these terms and get it back to its factored form. So doing it this way is sort of the easy way. When we see it like this, we have to tinker about to see what was the greatest common factor in each term, and then end up with this. So again, we're going to distribute, and we're careful of each sign. So a negative 3 times 4 is a negative 12. X to the second times x to the second, we add our exponents, x to the 4th. Now a negative 3 times a negative 6, that's going to give us a positive 18. X to the second times x, x to the 3rd. And then now this is this monomial times a positive 1, just becomes that. Now, as we get to item C here, and we'll clear that, here we have to be very careful. Again, we want to watch the signs, and then we want to be careful we get all the right values. So we know this is going to be a negative 7. Now we have x times x squared. This will be x to the 3rd. Y times y, y to the 2nd. Now a negative 1 times a positive 3 is a negative 3. X and x is x to the 2nd. Y and y is y to the 2nd. Now we have a negative 1 times a negative 11. That's going to give us a positive 11. And then we just put in our xy here. And it never hurts to go back and check again, especially when you're taking a test. And the textbook again shows us the process in great detail. Now, for this concept check here, see if you can pick out, and I've seen this happen when I check students' papers. See, this is the part that you're going to distribute. Here the student also distributed this to this one, which is a no. Can't do that. Okay? So be careful about that. You're only distributing, not this, to what is there. Okay, now example 3, where we're going to multiply a binomial by a binomial, and then later a binomial by a trinomial. And the pattern for this initially will be to do it this way. You're going to take the first term of your first binomial and multiply it by the second binomial. Then take the second term of your first binomial and multiply it by the second binomial. So the x times this, the 3 times this. So you set up two monomials times a binomial times a binomial. You get your results, and then notice the two middle terms here are like terms that we then join together. So we end up with usually a trinomial. Now notice that this is a factor and this is a factor. We are multiplying two binomial factors that eventually give us a product that is a trinomial. And I'm stressing this because later in this chapter we're going to take this trinomial and work it backwards until we are able to factor this into its factors. Now, some of you may be thinking, well, when we have a binomial like this, don't we use the FOIL? And the answer is yes, and we'll be treating that a little later. Okay, so when we multiply a binomial by a trinomial, again, the same process. We take the first member of the first binomial and multiply it by the second, in this case, the trinomial. And again, take the second member of the binomial and multiply it by the trinomial. And we end up with this long string of terms. We combine like terms and we get this. Now, what I'm going to suggest, and the text will suggest later, is that when we do this, we set it up vertically. Now, I did want to show you how to do it horizontally, but I like this method, again, for accuracy. So now what we're going to do is take each of these terms and multiply it by the top row. So negative 3 times 7 is a negative 21. Negative 3 times this is a positive 18x. Negative 3 times this is a negative 15x squared. Now you take your next term, 2x times this, and you put it in the like term column. 14x. 2x times this, and you get a negative 12x squared. And then 2x times this gives you a 10 x cubed. Now we have been suggesting this idea of vertical like term columns. So now when you add them up, now this is 1232. You then end up with it already as an answer, instead of trying to figure out what are my like terms here and then getting your answer. So to me, anytime you have a binomial times a trinomial, I would again, it's just, you could do it this way, but the idea of doing it vertically, and this is a skill we're going to be using. And I don't like to quote from the textbook, but look at this. Sometimes polynomials are easier to multiply vertically, in the same way we multiply real numbers. When multiplying vertically, we line up like terms in partial products vertically. This makes combining like terms easier. Okay. So in example 4, they actually do one vertically, and it's just the way we said, and you line them up once you get your partial products in like term columns. Alright, well, we've shown you a way to do it. Here is another way in objective 2. We're talking about a special way to multiply binomials, and that is we use what is called the FOIL, which is an acronym for the F is the first, the O is the outers, the I is the inners, the L is the last. It's just a method of multiplying when you have a binomial. So we often suggest you do something like this. First, which are these, and you multiply them, and that gives you 6x squared. Then you're going to do the outers, which is this one and this one, and would look like that. So 2x plus 1, and that gives you a plus 2x. Then the I is for the inners, this one and this one. This gives you a negative 9x. And then the L is for the last. And now notice you have 2 lines under each, so you've covered everything. This is a negative 3. Now again, generally you have like terms as your 2 middle terms. So you then go 6x squared. This is going to be a negative 7x and a negative 3. And then that is your results. And that's, of course, what they're describing here. What is this method? It's the FOIL. It's a special way to multiply binomials. Now this is crucial to master because, again, as I say later in this chapter, we're going to take this trinomial and we want to put it into its binomial factored form. And we do that by, in a sense, undoing what we've done, and then we always check it by the FOIL. Now this is going to be critical, and you might say, why? Well, I'll give you a little hint. Because later, our last section of our course, we take this trinomial, equal it to 0, we factor it, and then solve it. This gives us a way to solve quadratic equations now. And that's where we're going to end this course, using this skill of factoring. So in example 5, we're going to FOIL. X times x, and some students, I know I did this when I first did it, and I still do sometimes. X times x is x squared. The outers now, x times 2 is plus 2x. Inners, negative 1x. And then last, negative 2. Combine like terms, x squared minus x minus 2. I was a little distracted. That should be a positive x there in the middle as you combine these two. Okay, example 6. So, first, 6x squared. Outers, a negative 8x. Inners, a negative 21x. And last, a positive 28. So 6x squared minus 29x plus 28. Now keep in mind, we're going this way to get a trinomial that later in the chapter we're going to factor into its binomial factors. Now this one would be sort of easy. When they get to look like this, they're much more challenging, but we do have strategies that will show you to help. And in letter B, you see it gets more challenging already. But again, if you have a strategy, first, 15 x to the 4th. Outers, a negative 6x squared y. Inners, a positive 5x squared y. And now last, a negative 2y squared. Now you combine like terms. This will be 15x to the 4th. Now we have a negative 6 and a positive 5 will give us a negative 1 that we don't write, x squared y minus 2y squared. And normally after I do something like this, and it's a little complicated, I would pause again and check my work. And we see it here, correct. Okay, let's go on. Now, as we do things, there are special ways to do certain of our multiplications. In objective 3, they're telling us to square binomials. Now, here we have a plus b, the quantity squared. Well, we know that that equals a plus b times a plus b. So one way when we see a binomial that's squared is to just write it twice, and now we're going to FOIL. So first, a squared. Outers plus ab. Inners plus ab. Last plus b squared. Now we group like terms in the middle, and we get a squared plus 2ab plus b squared. And that's what they have here. Now, looking at this, can you see that when we do our outers and inners, we get the same thing? So in a sense, we're just doubling that. One of these, we double it. So this leads to a sort of a special recipe for squaring a binomial. And that's what I'm going to show you now. And this is the way we should do it. Now, a backup would be to do the FOIL. But this is the special recipe for squaring a binomial. We take the first term and square it. We multiply these two terms together and get AB. But then double it, because remember, the outers and the inners, we just double it. And then we square the last term. So from a binomial that we're going to square to its result, its product, we kind of skip this step. And we say we can do it this way, but this is the recipe for doing squaring a binomial. Now, when we do this, the product of squaring a binomial, which is this, is, we have a special name for it. We call it a perfect square trinomial. Now, you might say, well, why are we hearing that? Because if you see that you have a perfect square trinomial, this can immediately factor to a binomial square. So these two are like helpers of each other. This will FOIL through that special method into this, and if you recognize this, it will factor into that. Okay? Now, the only difference, if you have something like this, a minus b, the quantity squared, is that your middle term down here, instead of being positive, is negative. And they're giving this in the rule box. So, let's use our new recipe and follow along with this. Square the first term. That gives us x squared. Multiply these two together. That's 5x. Double it. Square the last term. And what is this called? A perfect square trinomial. All right, let's do b. I guess we have room right here. X squared. Multiply these two together, negative 9, double it, negative 18x. Square this, plus 81. What is this called? A perfect square trinomial. All right, square this. It's 9x squared. Multiply these two together. That's 6xz. Double it. 12xz. Square this term. 4z squared. All right, square this term. 16m to the fourth. Multiply these two together. 4 times a negative 3 is a negative 12. Double it. Negative 24 m squared n. Now square a negative 3n. Negative 3n times negative 3n is a positive 9n squared. And I think they have them all down here too. And they match what we've done. Now it takes a little practice, and again it's going to be an excellent tool in your dossier of doing things in math, especially the next course. Now I see a number of students make this error as well, that when you're squaring this, it becomes this, not that. And squaring this becomes this, not this. I see people leaving out that middle term. So be careful about that. Now, when we have something like this, that something we just completed, squaring a binomial, this is often referred to as special products. Now, another one that's similar to this is we have a plus b, a minus b. This is another type of special product. Now let's FOIL this and see what we get. Well, we get a squared for the first, outers a negative ab, inners a positive ab, last a negative b squared. Now when we have the arrangement as we see here, the items are the same, but the signs are different. This relationship, these are called conjugates, and write this in your booklet here too. These are called conjugates to each other. When we multiply conjugates, an interesting thing happens to the middle terms. They cancel out. And then we're left with a squared minus b squared. And this special product of multiplying conjugates is called the difference of perfect squares. Now, again, what's the big deal? Well, if you have the difference of perfect squares, they will factor always into their conjugates. So again, this is what we're building up toward in future lessons here in this course. We're going to be factoring these. So if you recognize that what you're dealing with, and a way to describe it is the product of the sum and difference of two terms, the sum of two terms, the difference of two terms. They don't introduce this word yet, but it'll be coming. They're called conjugates. When we multiply conjugates, the middle terms cancel out, and you get the difference of perfect squares. So let's do these. Remember, there's no middle term, so we're just multiplying the first and the last. So this will be x squared minus 9. This one will be 16y squared minus 1. This will be x to the fourth minus 4y squared. And this one's just a little tedious. So this will be 9m to the 4th minus 1/4. So all of these are the difference of perfect squares. That if you recognize this, they came from multiplying these conjugates and will factor into the conjugates. Now here we're getting into a little higher algebra where they, are just challenging you now that you are a little more mature and everything. So this is a form of squaring a binomial. So we're going to square this. In fact, let me write it up here. This will be 3 that we're going to square. Now we're going to multiply these two together. So it's 2 times this, and then double it. So this is going to be 6 times this. And then we're going to square this. And then looking at it this way, it's rather easy. So this is going to be 9. And this will be 12a. And this is going to be 6b. And then we're going to square that. And that's going to be 4a squared. Multiply these two together, double it, plus 4ab plus b squared. I kind of ran out of room there, but there it is. So not too bad. Again, it's recognizing this special one that they have here. And again, it's all there in your textbook. So for example 11, or I should say 10, we'll get to 11 in a moment. Again, I don't know if you can recognize this. This is in the form of a minus b and a plus b. So again, when you are multiplying this, there's not going to be any middle term, because these are sort of conjugates. So we're going to get a squared, which will be 5x minus 2y, the quantity squared, and just minus 1. So if you see that, this times this, these are the same, so it's this. So now you just do that special technique for squaring a binomial. 25x squared. Multiply these two together, get a negative 10, double it, negative 20 xy. Square this term, plus 4y squared minus 1. And there's your answer. Now they're showing you, again, more detail, but not necessarily needed. Let's go on to 11. In example 11, we see we have 3 binomials. So the general way to do this is you FOIL one of them, or a set of them, I should say. And this just gives you x squared minus 9 in this case. So now you have 2 of these that you're then going to say x squared minus 9, the quantity squared, and use that special technique. Square this first one. That'll be x to the 4th. Multiply these two together, double it, negative 18x squared. Square this last one, plus 81. And that's what they have. Okay, now for our last time. So there's our function. And they're saying our x value is this. So I've put it up there. So what do we do? Well, just carefully substitute. Our x value is this, so we go a plus 1, quantity squared, plus 5 times a plus 1 minus 2. So we use that special technique and get a squared plus 2a plus 1 plus 5a plus 5 minus 2. We combine our like terms, we get an a squared. We have a 2a and a 5a, that's going to give us 7a. Now we have a 5 minus 2 is 3, plus 1 over here is 4. Or you can get 6 minus 2 is 4, and of course that's what they get. Now, one of the things that they're going to show us here, which I think is a little bit interesting, is if you have a graphing calculator, that when you make this, put this function or a function similar to it into your graphing calculator, it crosses the x-axis at this particular point. So when y, what is the value of y here? Y is 0. We have seen where the parabola intersects with the x-axis, and our y value is 0. So here it looks like a 1, and maybe there like a something. This is something we'll be doing a little later on in that last lesson. And we describe this process as finding the zeros. Okay, let's get on to our mini lecture. This was rather a long one.